Sections 1 Fusion Welding Processes. What is welding? Oxy-fuel gas welding, arc welding, non-consumable electrode, arc welding, consumable electrode. Sections 1 Introduction to welding. Partial melting / fusion of two members along a joint, fusion welding. Fusing material by means of heat filler. Considerations, limitations. Sections 1 Oxy-fuel gas welding OFW. Any welding process using a fuel gas with oxygen to make a flame developed in the early 1900s. The flame produced is the source of heat. Common fuel gases are propane, acetylene, oxyacetylene. Gas welding is the most common variant. Flame temperatures of 6000 F. Sections 1 OFW continued. Flame types and filler. Oxygen to gas ratio neutral 1:1. Oxidation risk. Reducing less oxygen, less combustion. Low heat applications oxidizing more oxygen than Ly in copper applications. Filler rod or wire flux pressure gas welding. Sections 1 Arc welding. Non-consumable electric heat required for fusion is obtained from electricity. An electric arc is produced between the workpiece and an electric AC or DC power supplies. Polarity gas. Tungsten Arc Welding. GTAW TIG Plasma Arc Welding. PAW Atomic Hydrogen Welding. AHW. Sections 1 Gas Tungsten Arc Welding GTAW formerly TIG Welding. No flux. Uses: an inert gas argon, helium, etc. Filler rod DC at 200 A or AC at 500 A. Best for aluminum. Can weld a variety of metals. Contaminated electrode problems. Excellent surface finish and weld quality. Portable, versatile. Sections 1 Plasma Arc Welding. PAW developed in the 1960s. Temperatures exceeding 60,000 F. Ionized hot gas containing equal shares of electrons and ions. Highly concentrated filler fed into the arc, like GTAW. Shielding gas like argon, helium, etc. Transferred arc. Non-transferred methods. Deep, narrow welds. Great stability. Low thermal distortion. Sections 1. Sections 1 Atomic Hydrogen Welding AHW. Arc generated between two tungsten electrodes inside a hydrogen atmosphere. Arc is maintained separately from the workpiece. Temperatures of 11,000 F. Diatomic hydrogen molecules break down under the heat of the arc and recombine when they hit the workpiece, releasing energy. Sections 1 Arc Welding. Consumable electrode. Again, the heat necessary for fusion is derived from electrical energy. Electrode is consumed as process occurs. Filler shielded metal arc welding. SMAW. Submerged arc welding. Saw gas metal arc welding. GMAW. MIG flux core arc welding. FCAW. Electrode welding. EGW. Electroslag welding. ESW. Sections 1 Shielded metal arc welding. SMAW. Oldest, simplest, most versatile welding process. 50% of all industrial and maintenance welding. Stick welding. Simple equipment. Flag. Sections 1 Submerged arc welding. Saw weld arc is shielded by granular flux. Flux could be lime, silica, manganese oxide, etc. Flux is fed to the weld via gravitational feed. Hopper flux can be reused. Sections 1 Gas metal arc welding. GMAW. Commonly known as MIG Welding, developed in the 1950s. Uses the shielding gas argon, helium, CO2, etc. Cosumable bare wire is fed through torch. Multiple weld passes are easily accomplished. Low temperatures easy to handle. Very common ferrous and non-ferrous metals. Versatile, rapid, easy to learn. Sections 1 Flux core arc welding. Very similar to GMAW. Wire filled with a flux. Slag is easily removed. Very versatile. Common steel welding process. Alloying can be accomplished. Easy automation. Sections 1 Electric welding. EGW. Machine welding process. Vertical welding in one path but joins edge to edge. Flux core or shielding gas. Industrial applications. Reliable, Sections 1 Electroslag welding ESW similar in application to EGW. Arc is between machine and workpiece. Flux is added / melted by arc. Arc is only a unit at the outset of the welding pass, not strictly an arc welding process. Excellent penetration, good for thick pieces. Many industrial apps. Electrode coating out.